Okay, on this video I'm going to do two examples of applications on how to use the difference quotient to answer questions. So on this one we're going to talk about horizontal tangent lines, and if you look at a horizontal tangent line it would look like this. They're usually y equals a number, and that's wherever it crosses the y-axis, and if you'll remember the slope is 0, which is our derivative is going to be 0. So we want to know at what point. So basically we're trying to find the points on the graph where the tangent is 0, the derivative is 0, or the slope is 0. And this is our function. Now if you recall, this is a parabola, and if we look at a parabola, if I drew a horizontal tangent line right here, the slope would be 0, so I just kind of need to find that point where that happens. So let's find the derivative. So if we're going to use f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now this is a little bit different because we've been using a's because we actually have a point here. Here we have no clue, we just know the slope is 0 or the derivative is 0. So we're going to leave the x's right in the formula so that we can find out what x's have a slope of 0. So I am going to do f prime of x as the limit as h approaches 0. And here I want to do f of x plus h. Well, here's my original function, so I'm going to put x plus h here and x plus h here. So it's going to be x plus h squared plus 4 times x plus h minus 1. Then I'm going to take away or subtract f of x, which is that whole thing. Remember, use your parentheses so that you watch your signs. All over h. Now basically here it's a matter of algebra to get this down where we can put this equal to 0, because that's what we have to do to find out what x's have a slope of 0. Now on the side here if you want to, but you guys should be getting better at this, but I need to simplify that. If you do x plus h times x plus h on the side, because I got to multiply that out, it'd be x squared plus 2xh's plus h squared. So I'm going to put that in that spot here. So I have f prime of x is the limit as h approaches 0 of x squared plus 2xh plus h squared. Then do the distributive property, plus 4x plus 4h minus 1. Distribute this negative through, minus x squared minus 4x plus 1 all over h. And I always like to check and make sure that everything in the back and this after the subtraction should be canceled. So let's look at that. X squared, negative x and x, so that cancels. Negative 4x and a 4x, that cancels. And I have a negative 1 and a 1, so that cancels. So I can say, thanks for playing. All of these cancel each other out, which makes it nice. I have f prime of x is the limit of h approaches 0 of 2xh plus h squared plus 4h all over h. Now I still can't plug my 0 in, so I'm going to continue on, and I'm going to factor out an h in the numerator so I can maybe plug in my 0. So if I take an h out, I have 2x plus h plus 4 all over h. These I can cancel out and make a 1. Thanks for playing. So that's the limit as h approaches 0 of 2x plus h plus 4. And then I put in my 0 for h. So I get 2x plus 4. So basically I found that f prime of x is 2x plus 4. That means I can plug in any x I want and I will find the slope at that point because the f prime shows the derivative. So this is, we're not done yet. This is actually what it is, but now we have to find the points where the slope is 0 or the derivative is 0. So we're basically going to take this and put it equal to 0. And when I solve for this, I get x to be negative 2. Alright, but that's not the point. That's just the x value. How do I get the y? Well, you have to actually plug the negative 2 back into your original. So let's do f of negative 2 to see what the y value would be. And when I do, I have 4 minus 8, that's negative 4 minus 1, so it comes out to be negative 5. So it's at the point 2, negative 5. And that's our answer, where we found a horizontal tangent line because the slope is 0. Now I've graphed this, so let's look at it. Now when I come over here to the graph, this is what I want. And it looks like it's the point negative 2, 5, but your calculator, so if you put this in your calculator and look at it, now if you go to the menu, it does do the derivative, and you're not used to this terminology, but see where it says dy dx, looks like slope delta y over delta x. If you click that, and then right in that position, I want to know what the slope is at negative 2, so we're going to put negative 2 right in here, hit enter. It tells you the slope is 0, so we did the right thing. We can even draw a tangent line if we wanted to there by doing menu, and it's underneath geometry, and we can do points and lines, and we want to do a tangent, and we want it to be right there, and we can, it tells you the tangent line is y equals negative 5. So that is our horizontal tangent line at the point negative 2, negative 5, where the slope is 0. All right? Let's look at this next problem. This next problem will be a little bit long also, so try to use every spot you have. This one's a little bit longer than the other one. So we want to find the equations of the lines having a slope of negative 1. So again, when I see the word slope, I think derivative, and I know my slopes are negative 1, so I've got to find the equations of lines that have the slope of negative 1. So we have to actually find the equation of the lines of this one, and that they're tangent to this curve. All right? So let's do the derivative so we can figure out what x values we're talking about. So we have f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. And when I use this function to do that too, I have f prime of x is the limit as h approaches 0 of 1 over x plus h minus 1. All I did was put the x plus h in that spot. Minus 1 over x minus 1, because that's f of x, all over h. Now when I look at this, this is a complex fraction. So we're going to multiply everybody by the common denominator. And the common denominator, because this is over 1, is going to be this and this. Alright? So I'm going to do this in a different color so maybe you can see it better. So I'm going to multiply everybody. Oops, I didn't change it, did I? Let's try that again. So I'm going to multiply. It doesn't want to change, does it? This is my third time. If it doesn't change, there we go. So I'm going to multiply everybody by x minus 1 times x plus h minus 1. And the whole idea why we do this is to, it's a complex fraction, is to make it a little bit easier to look at so we don't have fractions within fractions. So let's look at this. Equals the limit as h approaches 0 of, now this will cancel, x minus 1 minus, this will cancel. I'm going to keep the parentheses there so I don't make a mistake. All over. Now the denominator looks like a big mess, but leave it in factored form. Don't multiply it out, you'll be sorry. Just leave it like that. Okay? Now as I do this, I can see that the f prime of x, we're getting a little bit closer to something a little bit nicer, as the limit as h approaches 0. And you'll see this is really a minus x, a minus h. Let's make this a little nicer for you to see. This is minus x minus h plus 1. So if you'll notice again that this will cancel, okay? And I'll say, all right, that's good. And then I have a minus h, and the x's will cancel. So I end up having a minus h in the numerator. That's all I have left because everything else cancels. So this will cancel, and this will cancel. So it's a limit of negative h, okay, all over h times x minus 1 times x plus h minus 1. Now, all these are factored. I can cancel it out. It's really a negative 1. So I have is the limit as h approaches 0 of negative 1 all over x minus 1, x plus h plus H plus h minus 1, sorry. Now we're going to plug our 0 in, so I don't have to write the limit anymore. Which is going to equal negative 1 over x minus 1 squared. So we just found the derivative of this function. Now let's answer the question. We need to find equations of lines, but before we even do that, we know that the slope, we're looking for slopes of negative 1. Well, if this is our slope equation, if you will, if I put this equal to negative 1, we can find the x values where that happens. So that's what we're going to do. So what we're going to do is take this and put it equal to negative 1 and figure out when that happens. So if I have negative 1 over parentheses x minus 1 squared equals negative 1, I'm going to put this over 1 and cross multiply, so you end up getting negative 1 equals negative x minus 1 squared. Divide by the negative, so you have 1 equals x minus 1 squared. See how far down on this paper I can go. Okay, so I have 1 equals x squared minus 2x plus 1. Now the 1's are going to cancel, so I end up having x squared minus 2x equals 0, because the 1's will cancel out. Now if I'm going to bring this up here, I want to find what x's I have. I'm going to factor out an x. I have an x minus 2 equals 0. Make your big T, so x is going to equal 0 and x minus 2 equals 0, so x equals 2. So I actually have 2 points this happens. I have it at 0 something and at 2 something. So when I plug 0 back into my original to find out what point that is on my graph, if I put a 0 in there, I'd have 1 over negative 1. So this is negative 1. It happens at the point 0, negative 1. Now if I plug a 2 back into the original, I have 1 over 1, or this happens at the point 2, 1. So that's nice to know. At those 2 points, my slope is 0, but they wanted equations of tangent lines, so we're going to make 2 of them. So the first one is y minus y1 equals m x minus x1, and we're going to throw in this point, and we got to find the slope at that point too, which we know is negative 1. So I have y minus, we'll use this point first. Okay, we'll use this point first. So now I'm going to put y plus 1, because a negative 1 in there will turn that slope is negative 1, x minus 0. So y is going to equal negative x minus 1. So there is our first tangent line. Our second tangent line, we're going to use the same formula here. And now I'm going to plug in the other point right here to find out what the equation of that tangent line is there. So I have y minus 1 equals slope, which is negative 1, x minus 2. So this comes out after we've multiplied all through as y equals negative x plus 3. And there's our other tangent line. So we found the 2 tangent lines. Now, in order to show this on the graph a little bit better, I've got this on the graphing calculator too. And if you'll see, the first point was 0, negative 1, so that's basically right here, okay? So there's a tangent there. So if I want to make sure, if I did menu, and I want to analyze the graph, and I want to find the slope, or the dy dx, at negative 2, so I'm going to put in, excuse me, at 0, because that was the first point, and I hit enter, you'll see right here is the point that I want. And if I want to know what the slope is there at that point, I do menu, analyze graph, and I want to know the derivative. And did I want it at 0? Yes. It's 0, and I hit enter. It tells it's negative 1. Alright, then you can do menu, and you can do geometry. You can put in your line, and you can do your tangent right here. And it will tell you it's the line y equals negative x minus 1. And we can do the same for the other. Menu, analyze graph, do your derivative, and I want to find the other one was at the point 2, 1. So we're going to put 2 in there, hit enter. See, the slope is negative 1. Now let's do our tangent line. Menu, geometry, we want to find a line, and it's a tangent line right here, so we're going to click on it, and it tells you that's y equals negative x plus 3. So your calculator is pretty good at checking things, but you need to make sure you show all that algebra we showed on the other page. Okay? All right, that's it for this video because those were two long problems.